Hello everyone. In today's quick video, we're gonna briefly talk about sorting algorithms. Sorting is fundamental and probably is one of the oldest problems in computer science. In today's tutorial, there's only two things that you need to remember. The first one is the best sorting algorithm has the time complexity of O n log n. We have a lot of sorting algorithms. For example, quick sort, merge sort, bubble sort, and dozens more. You can see the list from Wikipedia for available sorting algorithms. But it's not the name of the sorting algorithm that we need to remember. What we need to remember is the best sorting algorithm has the time complexity of O n log n. For example, we have merge sort and quick sort. Both have O n log n in time complexity. And merge sort actually uses divide and conquer algorithm, which we have learned in the previous tutorial. Now it's also worth to mention that the worst sorting algorithm has a time complexity of O n squared. And why do we need to know this? We need to know and remember this because sometime in your algorithm, you want to use the sort function and you must know that already take O n log n time complexity to add up to the overall time complexity of your algorithm. Next, the second thing you need to remember today is if we are allowed to sort, we probably can have the top time complexity of O n log n. That means if your current solution has a time complexity of O n squared or more, sorting might be able to bring it down. And the lowest time complexity with the help of sorting is O n log n, because sorting itself is already take O n log n. Let's have a look at this problem. We are given an array of numbers, and we are asked to write a find2 function that to find two numbers that can add up to a given sum. We can see an immediate solution with brute force. That's gonna give us the time complexity of O n squared. We need two for loops. The first one to pick the first number, and the second one to pick the second number. And then we can choose the two numbers that add up to the sum. So that is brute force with O n squared time complexity. We can do better than this. If we sort and use binary search, it's gonna give us O n log n. So first, we sort the array small to big. That's gonna take O n log n. And then we're gonna do a binary search nested in a for loop. That's gonna give us O n log n again. So we pick the first number with for loop, and then we pick the second number with binary search. So that's gonna give us O n log n, and in total it's gonna give us O n log n time complexity. And that is much better than O n squared. So that is how sorting can help to bring down the time complexity of your algorithm. That is all for today's tutorial. Thank you for watching, and I will see you in the next video.